This tutorial is a short introduction to oxidation reduction reactions. Oxidation reduction reactions are often referred to as redox reactions. For definition purposes, oxidation means that an element has lost electrons during a reaction. Usually these elements have lower electronegativity values and very often form positively charged cations as the result of this oxidation. Reduction, on the other hand, is the gain of electrons during a reaction, usually involving an element that has a higher electronegativity, and these elements often form anions as the result of this reduction reaction. For redox reactions, the number of electrons gained must equal the number of electrons lost during the reaction. Combustion reactions are all redox reactions. Most metabolic chemistry and biochemistry involves redox reactions. Battery chemistry, of course, is all redox, and even something like metal refining is redox chemistry. Well, let's talk about a few definitions related to redox chemistry. Oxidation state or number is the gain or loss of valence electrons during the course of these reactions. For monatomic ions, this oxidation state or oxidation number equals the charge on the ion. So iron +3, the oxidation state of iron is +3, chloride oxidation state is -1, calcium +2, sulfur as sulfide a -2. Elements that are bonded to themselves by definition have an oxidation state of 0. So in O2, oxygen has an oxidation state of 0. N2, nitrogen has an oxidation state of 0, and so on for these atoms bonded to themselves. Similarly, metallic elements have an oxidation state of 0. Occasionally, we will put a 0 as a superscript where we would normally put the charge for an ion, but not always. So Fe written with no plus charge on it means Fe0, oxidation state of 0. In ionic compounds, the charge on the element is the oxidation state. So in FeO, the charge on iron is +2. In Fe2O3, the charge on iron is +3. Aluminum oxide Al2O3, the charge on aluminum is +3. Sodium chloride, the charge on sodium is +1, the oxidation state is +1. The charge on chloride is -1, the oxidation state is a -1. In calcium chloride, the oxidation state for chloride is still a -1, the oxidation state for calcium +2. We often talk about oxidizing agents, which are reactants which cause materials to be oxidized. When we take a look at oxidizing agents, we will find that the agent itself is reduced, accepting electrons from the material being oxidized. Similarly, we'll talk about reducing agents, materials that cause something to be reduced. If the material is being reduced, if it's accepting electrons, then the agent itself must be giving up the electrons, and our reducing agent is being oxidized. Let's take a look at some quick redox example problems. Here we have iron busily oxidizing or rusting out in the environment in this balanced chemical reaction. If we take a look at the oxidation state of iron before and after the reaction, we see that the iron atoms have lost 2 electrons, clearly in oxidation. The oxidation state in O2 for oxygen is 0. In FeO, the oxidation state for oxygen is a -2. Clearly, oxygen has accepted electrons and oxygen has been reduced in this reaction. We can have a very similar reaction forming a different type of iron oxide. In this case, iron is going from 0 to +3, each iron atom having given up 3 electrons, being oxidized. Oxygen, again, going from 0 to a -2, being reduced. We need to make sure that we have these balanced from an electron point of view. We have 2 irons, each giving up 3 electrons, for a grand total of 6 electrons being given up during the oxidation. We have 3 oxygens each gaining 2 electrons for a -6 in our reduction, plus 6 equals -6 for the number of electrons transferred, so the equation is balanced. Many of you have seen videos where we've taken sodium metal and added it to water. Sodium going from an oxidation state of 0 to +1. We have 2 sodium ions each giving up 1 electron for a grand total of 2 electrons. In water, oxygen is a -2. In hydroxide, oxygen is also a -2. So there's no change in oxidation state during the reaction for oxygen. Hydrogen, on the other hand, goes from a +1 to 0 when we're going from water to hydrogen gas, and as a result is being reduced. Sodium is being oxidized, hydrogen is being reduced during the course of the reaction. If we take hydrogen sulfide, H2S, and react that with oxygen to produce sulfuric acid, we see that hydrogen is +1 both as a reactant and product, not changing oxidation state. Sulfur, on the other hand, goes from a -2 to a +6. That sulfur atom has lost a total of 8 electrons. Oxygen starts out with an oxidation state of 0, goes to an oxidation state of -2, gaining 2 electrons. There are 4 oxygens, having each gained 2 electrons for a grand total of 8 electrons gained. Sulfur lost 8 electrons, we're balanced. And sulfur is being oxidized, oxygen is being reduced during the course of this reaction. When we take a look at covalent compounds, we evaluate the oxidation states based on the electronegativity differences between the atoms bonded together. So if we take a look at a reaction where we're going to burn methane in the presence of oxygen to give ourselves carbon dioxide and water, although we say that carbon-hydrogen bonds are nonpolar, there is a slight difference between the electronegativity values for carbon and hydrogen. Carbon is slightly more electronegative, and as a result, we're going to say that carbon is a -4 in methane. But when we get to carbon dioxide, where oxygen is a higher electronegativity than carbon, we're going to say that carbon is a +4. So during the course of this reaction, carbon goes from a -4 to a +4, which is a loss of 8 electrons. If we take a look at hydrogens, we see that hydrogen is +1 on both the reactant and product side of this reaction. Hydrogens do not change oxidation states. On the other hand, oxygen goes from 0 to a -2 in carbon dioxide, or 0 to a -2 in water. If we go ahead and evaluate all of those gains in electrons, we see oxygens have gained a total of 8 electrons. Carbon has lost a total of 8 electrons. In this reaction, carbon is being oxidized and oxygen is being reduced. To loop back around to our definitions of reducing agents and oxidizing agents, in this reaction, carbon is the reducing agent because carbon is forcing the reduction of oxygen. Oxygen is the oxidizing agent because it is forcing the oxidation of carbon in this reaction.